Well, hello everyone, and welcome to We Need Our Space Live. And today we are going to be talking about Mars and some high resolution images captured by something called HiRISE. So we're going to find out what exactly is HiRISE and take a look at some of these pictures and see what these pictures are actually all about. So let me take myself out of here, because if we're going to be looking at high resolution images, you don't want to be looking at me. So let's just begin here. I guess I should probably answer the question. Why are we even talking about Mars today? Well, Mars will be at its brightest and best in mid-October this year, as Halloween approaches, as so many people are eagerly awaiting. Well, it will reach its brightest and best in around mid-October this year. Now, whenever it comes to opposition is when the Earth, the Sun, and Mars are aligned in a straight line. So let's take a look at some of the best close-up images by the Mars Reconnaissance Orbiter, which circled the planet in 2006. It came up with some brilliant images. So let's take a first look here at what this looks like here. Well, the spacecraft has a device called the High Resolution Imaging Science Experiment, or HiRISE. It's the most powerful camera ever sent to a planet. Now, the images it sent back from Mars are pretty astonishing and can resolve features on the planet down to a little more than 3 feet across. It can also do this pretty quickly. It can acquire images up to 28 gigabytes of data in just 6 seconds. So HiRISE is used to study active surface processes and the evolution of landscapes. It's also used to help identify suitable landing sites for robotic and future human exploration. It's kind of important. So let's take a look at our first image here from HiRISE. This is called River of Sand. So whenever you look at it, you're viewing this in infrared color. It looks like a wavy river flowing through a steep walled canyon. But the ripples you see here at the bottom are actually dunes created by wind. These are called transverse aeolian dunes, or TARS. Cerberus fossae are a series of broken up fissures along the dusty flatlands in the southeastern region of Mars known as Elysium Planitia. This zone of rifts are thought to be a result of volcanic tectonic processes. You can see the dark sediment that has accumulated at the bottom of the floor of this particular fissure. So the dark blue color you see is the result of looking at the area through infrared color. The sand lining the floor looks blue against the light-toned dust covering the region. Combine this with the ripples of the TARS and it gives the impression of a river cutting through the Martian plains. Just adjust something here real quick. Sorry, I had to adjust my mic there. Okay. Oh, well, okay, let's take a look at our second image here. Now, whenever you look at this image, it looks like, it almost looks like bullet holes in glass or some type of weird infection. There's these spider vein features here. What you're seeing here is actually channels of bright white carbon dioxide ice that appears seasonally in the polar regions. During the springtime, the sun warms it and causes it to sublimate. Say that with me, sublimate. Now, sublimation is when something goes from ice to gas and it skips over the liquid stage, or solid to gas and it skips over the liquid stage. It's kind of like what comets do. Comets are these dusty, dirty balls of ice kind of circling our solar system here. Whenever they approach the sun, The comet ice goes from ice directly to gas, and it skips over that liquid stage. That is called sublimation. So essentially, this is dry ice, and dry ice it's kind of that stuff that you see in the Halloween punch bowls. It makes it look kind of spooky. It has this kind of billowy, smoky, hazy kind of effect. Well, that's dry ice, and dry ice goes from solid to gas, and it skips over the liquid phase. That's called sublimation. What you're seeing here are the eroded channels filled with bright ice set against the muted red of the underlying layer. Whenever it is summer, the ice will disappear into the atmosphere, and then you'll see the channels of ghostly spiders carved in the surface. This is something that happens only on Mars. You won't see this type of formation on Earth because Earth's climate is way too warm. Now let's move on to our next picture. This crazy picture here. It kind of looks like a ghostly picture. Well, this image is called the Serpent Dust Devil of Mars. It looks kind of like a ghost or a spectral worm. This whole dust devil casting a shadow into the ground, it reaches about a half a mile in height. The arc of the plume was produced by a westerly breeze at about 820 feet high up in the air. Now that blew the top of the plume towards the east. The dust plume itself is about 98 feet in diameter. So this was photographed in the late springtime in a place called Amazonas Planitia. It was taken during a time of the year where Mars is the farthest from the sun. Just as on Earth, Martian winds are powered by solar heating. Exposure to the sun's rays should be at a minimum during this season. Yet even now, dust devils act relentlessly to clean the surface of freshly deposited dust, a little bit at a time. As I enjoy a little bit of coffee here. Okay, let's go ahead and move on to our next astonishing picture here. Well, this is called Polygonal Puzzle. These don't really have names. This is just what I'm calling them for right now. But this is it looks like a polygonal puzzle. Or some type of abstract art. Well, actually what you're seeing here is actually sand dunes. These polygons form when ridges of dunes intersect with one another. In this image, the light comes from the upper left-hand corner. And all the boulders and other debris can be seen in the base of some of the polygons. Polygons are of great interest because they often indicate the presence of shallow ice or of desiccation, such as in a mud flat. Polygons formed by the intersecting ridges of sand dunes. If this deposit were to become inundated and eroded, we might not be able to tell that they originated as wind-blown dunes and interpret the polygons as evidence for a dried-up lake. So dunes often accumulate in the bottoms of craters, also a good setting for a temporary lake. This other image here is pretty cool, pretty interesting. It'd be a great framed photograph, I think. This is the Draw of Mars. The Draw of Mars. It's not just a Michael Bay film. Well, the Draw of Mars here. Well, scientists classify sandy landforms by the wavelength or the length between the crests. There's ripples, tars, as I previously mentioned, dunes, and finally a mega dune called a draw. A draw is greater than 1 kilometer. This image is a close-up image of a draw, with ripples stippling its precipitous faces. These are very uncommon on Mars. They likely take thousands of Martian years to form, possibly even longer. So again, ripples are the smallest bed forms. They're less than 20 meters. And then you've got the tars, which are slightly larger. I guess around, they are 20 to 70 meters. And then you've got the dunes and you have the draws. Draws are the highest order bed forms with the largest wavelengths. So let's move on to this creepy image here. Kind of keeping, we're not even in Halloween yet, so I don't know why I'm doing creepy images here, but so this image here looks almost like brain matter or an image of a brain. But this is not an image of a brain. This image is a close-up image of an ice cap located at the northern pole of Mars. So this is a combination of carbon dioxide and water frost during the Martian winter. Well, in spring, these low-lying hummocks, only about a meter in height, begin to disappear. Once they begin to disappear, we can begin to see the surface features of the ice. So the ice cap would be a bad place to get lost. It's one of the smoothest, flattest places on Mars, so there are no landmarks visible. Scientists don't know what makes this pattern so uniform over such large distances. Well, by using the HiRISE images like this, these small differences in these icy features from one another, this will help us understand the current climate and meteorological conditions at the North Pole of Mars. Well, I hope you enjoyed that little bit of a look at the surface of Mars and the HiRISE imaging system here from the Mars Reconnaissance Orbiter. Have a wonderful night and a fantastic rest of your week. See you next week, folks. I'm out.